Hi everyone, welcome to Mr. Wagon's math class. Do you remember Pythagoras, the father of numbers, that who said numbers rule the universe? So numbers are around us everywhere. And we know the number line that has 0 in the middle. You go to the right, that's the positive numbers. Go to the left, those are the negative numbers. Numbers written in different ways, such as fractions, half. And I know where to put this half on the number line. It's between 0 and 1. Or decimals of negative 3.12 as an example, and I know where to put that on the number line. Go to the negative 3, between negative 3 and negative 4, but it's closer to the negative 3 to put that decimal on the number line. Or it could be symbols, just like pi, but I'm not talking about the pie you eat. It's the symbol pi in math. The value of pi is 3.14. So go to the positive 3.14, estimate where it goes, and pi goes right after 3.14. Or it could be square root, cube root, just like the cube root of 8. If I evaluate the cube root of 8, it's 2 times 2 times 2. So I know where to put the cube root of 8 right on 2. We also talked about perfect squares. What are perfect squares? For example, 4. What's the square root of 4? I want you to get a calculator and put 4 on it and square root it. What did that give you? Exactly 2. So the square root of 4 equals 2 because, watch this, if I take 2, multiply it by 2, gives me exactly 4. So the square root of 4 equals 2 because 2 times 2 equals 4. On the number line, I can put the square root of 4 exactly right on 2. Now, what about the square root of 3? Again, on the calculator, I wanted you to try and find the square root of 3. So put 3 and square root it. Watch how it gave me a number. And I wanted you to know that there are more numbers to the square root of 3, but the window of this calculator fits that many only. So now, what if I take this number and multiply it by itself? Would it give you 3? Let's see. Multiply it by 1.732050807. What would that give you? Watch how it gave you 2.99999. It didn't give you 3. Why is that? Because 3 is not a perfect square. So the square root of 3 equals 1.73. To estimate or to find where would you put that square root of 3 on the number line, you have to estimate between 1 and 2, but it's closer to 2. And this takes us to today's lesson about classifying real numbers into rational numbers and irrational numbers. What is the difference? Let's take it step by step. If I start with all positive number from 1, 2, 3 to infinity, those called natural numbers. What if I add the 0? This is called whole numbers. So the whole numbers are all positive numbers, including the 0. Now 0 is not positive or negative. So where can I put the negative numbers like negative 1, negative 2, negative 3? Where does those go? Those called integers. So integers are all the numbers that are positive, negative, including the 0. Now, fractions and decimals, how do I classify those? For example, negative 7 over 2, that's a fraction. But if I divide 7 divided by 2, gives you negative 3.5. Watch how the decimal form of that fraction terminated, which means 3.5 and that's it. There is no any other number. What about the fraction 10 divided by 3? If I divide 10 divided by 3, that gives me 3.33333. So that 3 repeats, but I'm not going to keep writing 3's. So I put 3.3 with the dash on top of the 3. That means that 3 is repeated. So all fractions and the decimal form that repeats or terminates are called rational numbers. So now rational numbers are all the positive numbers, the 0, the negative numbers, all the numbers that you can write them as a fraction, or the decimal form that repeats or terminates. What about other numbers? So what is irrational number? Irrational numbers are all the numbers that does not repeat nor terminates. They're not perfect square and they're not perfect cube. For example, pi is the irrational number. The cube root of 6 is not a perfect cube, so it's irrational number. Any number multiplied by pi is irrational number because pi is irrational. The number 3.1428571 with all these dots, that's in fact what pi is. And the 3 dots means it continue going, but it does not repeat the same numbers. So that's an irrational number because it does not repeat nor terminates. The square root of 2 is not a perfect square. It's an irrational number. Now let's practice classifying real numbers and justify the reason why. I will keep the chart for you to remember how to classify whether the number is rational or irrational. Let's start with the negative square root of 9. Evaluate that first. The negative square root of 9 equals negative 3. Look at the chart. Negative 3 goes into the integers. So it is an integer. And it is a rational number. 72 over 2 is a fraction. For me to decide whether it's rational or irrational, I need to find the decimal form. So divide them gives you exactly 36. And 36 is a positive number. It's an integer. It's rational. So for me to classify it, it would be a natural, whole, integer, and rational number. Now pi, we all know that the decimal form never repeats or terminates. Watch, it becomes irrational number. The cube root of 2, because 2 is not a perfect cube, then it's irrational number. Now watch this number, 0.13, then 133, then 1333. Watch how they keep adding 3 to the repeated form. So the number does not repeat nor terminate. Those dots means does not terminate. And they did not repeat 1, 3. They kept adding that 3 to it. Now how can you estimate the value of the square root of 70 to the nearest integer without using a calculator? So we're not going to use a calculator to find the square root of a number. 70 is not a perfect square. So there isn't a number. I multiply it by itself, gives me 70. So what do? The first thing is to make a table with 3 columns and 2 rows. In the middle, put the square root of 70. Now think about a perfect square less than 70. It's 64, and I need the square root of 64. And I need a perfect square more than 70, which is 81, but I need the square root of 81 because I'm trying to find the square root of 70. Now evaluate those square roots. The square root of 64 is 8. The square root of 81 is 9. Now I know that the square root of 70 is going to be between those two numbers. So on the number line, the square root of 64 equals 8. The square root of 81 equals 9. So I know the square root of 70 will be right in the between 8 and 9. Since I am estimating to the nearest integer, so is it closer to the 8 or is it closer to the 9? How would we decide? Watch how 70 is only 6 away from 64, and 70 is 11 away from 81. So it is closer to the square root of 64 instead of the square root of 81, which means the value of the square root of 70 is closer to the integer 8. And we use approximately, so the square root of 70 approximately 8 to the nearest integer, which means there's no decimal or fraction with that number. So you put the square root of 70 close to 8. Now, how can we estimate the square root of 70 to the nearest 10th place? And I know from what I've done before that the square root of 70 is closer to the 8 than the 9. It's not right in the middle. So as a decimal, I know it's going to be less than 8.5. So again, make a table with the square root of 70 right in the middle. But this time, I am going to start with the opposite, which means the answers. Because I know it's not going to be 8.5, so I'm going to put it between 8.5 and 8.4 and see, is it closer to the 8.4 or closer to the 8.5? To do that, multiply 8.4 by itself. What would that give you? 70.56. And multiply 8.5 by itself. What does that give you? 72.25. But again, because I'm looking for the square root, that's why I put them in the square roots. Now on the number line, here's the square root of 70.56 is equal to 8.4, and the square root of 72.25 equals to 8.5. So is the square root of 70 closer to the 8.4 or closer to the 8.5? Again, watch how 70 is only 0.56 away from 70.56. So I will put it closer to the 8.4. Approximately, the square root of 70 would be 8.4. Now that we know how to classify and evaluate numbers, let's answer this question. Classify and list the real numbers from least to greatest. The first one is pi square root of 4. Right away, this is an irrational number because you have pi. But for me to put it on a number line, I need to evaluate. Pi is 3.14. The square root of 4 is 2. Multiply them, you get 6.28. Now look at the number line to 6.28 and put pi square root of 4. Now I need negative square root of 61. I know 61 is not a perfect square. Therefore, negative square root of 61 is an irrational number. But how do I evaluate this to put it on the number line? The closest perfect square is 64. So the negative square root of 64 equals negative 8. So approximately, it's going to be close to negative 8 on the number line. To be more precise, I find the 10th place. Because 61 is less than 64, then it's going to be between 7 and 8. The square root, the negative square root of 61, approximately negative 7.8. And if you choose negative 7.9, that's fine because 61 is so close to 64. So on the number line, negative square root of 61 goes right on negative 7.9 or 8. Now the last one, 2 2/3. Evaluate, change that into a decimal first. 2/3 is 0.666. So the answer is 2.6 with the dash on top because that repeats. Therefore, that number is a rational number because the decimal form repeats. So where would I put 2 2/3 on the number line? Go at 2.6 and put that number 2 2/3. Now I know how to organize them or list them from least to greatest. Look at the number line, start from the negative or the far left of the number line, which is negative square root of 61, then 2 2/3, and the last one, or the biggest number, is pi times the square root of 4. So let's review now what we learned so far about rational numbers. Rational numbers can be written as a fraction. The decimal form repeats. For example, 2.12121212, or you can write it as 2.12 with the dash on top of it. That means 12 is repeated. The decimal form terminates, which means, as an example, 9.5, nothing else. Perfect squares, the square root of 64, for example. 64 is a perfect square. A perfect cube, the cube root of 27, because 27 is a perfect cube. All these are rational numbers. What about irrational numbers? Irrational numbers cannot be written as a fraction. And I will explain that in the next lesson. Why? The decimal form does not repeat. As an example, 4.91, and then if you add any other number to that, it's not repeated. The decimal form does not terminate, which means it keeps going forever, like 9.1267, and you see those 3 dots, that means it keeps going forever, so that means it does not terminate. Not a perfect square, for example, the square root of 12, that isn't a number I multiply it by itself, will give me exactly 12. Not a perfect cube, for example, the cube root of 7, that isn't a number I can multiply it by itself 3 times, gives me exactly 7. And those called not perfect cubed. So all these are irrational numbers. This is it for today's lesson about classifying numbers into rational numbers and irrational numbers. We're able to evaluate without using a calculator the square root of not a perfect square. Thank you for subscribing to my channels and liking my videos. If you have any question or comment, please write it below and I will answer that as soon as I can. To learn the next lesson about writing rational numbers into fractions and why we can't write irrational numbers as a fraction, watch the next video that would help you out. See you next time.